Question 8, we have a forestry company owning 7,000 trees, and they're going to cut 12% of them and plant 600. So this is a difference equation. So let's see what's happening here. What would happen after year one? We're getting rid of 12%, so we're going to have 88% of 7,000, and we're going to add on 600, which is 0.88 of U0 plus 600. That's U1. What would U2 be? The answer to this, I think, is 6160 plus 600, 6760. So the next year will be equal to 0.88 of this amount, which is U1's total, and then plus 600. And U1 is this expression here. So to keep it all in the same terms, we're going to have 0.88 times 0.88 of U0 plus 600, and then this plus 600 is outside. So we have 0.88 squared times U0 plus 0.88 times 600 plus 600, and this repetition will keep on going, so we can separate it into 0.88 squared U0 plus my Sn, my sequence, my Sn terms that we're going to add together, a times 1 minus r to the power of n over 1 minus r. So if we reverse this sequence around, we have a is equal to 600, and the ratio is 0.88. So 600 by 1 minus 0.88 to the power of n over 1 minus 0.88, which is 0.12. And 6,000 divided by 0.12 is 5,000, or 600 is 5,000. So we're going to have 5,000 times 1 minus 0.88 to the power of n. So we are going to get 5,000 by 1 minus 5,000 of the 0.88 to the power of n's. So bringing this guy down, U0 is 7,000. So we have 7,000 0.88 to the power of n's. We're going to have to take away 5,000 of them. This 5,000, and we're going to have to add on 5,000, and this will be my UN. So we're going to have 2,000 by 0.88 to the power of n plus 5,000 for the amount of trees. Part 2, we're asked to find U10. Try and use your calculator there, just sub it in. 2,000 by 0.88 to the power of 10 plus 5,000 is going to be 5,557. Second part is, if the forestry company follows this model indefinitely, what will the trees eventually settle at? So as n tends to infinity, this will tend to 0. So therefore the trees will settle around 5,000. In B part 1, we're asked to solve the difference equation. So we're going to have UN is going to be my x squared, and I'm going to have plus 4x plus 4 is equal to 0. So this is just one solution, x plus 2 squared. Sometimes we get 2. So we just have 1 here, x is equal to minus 2. And difference equation formula is L alpha to the power of n plus m beta to the power of n for 2 roots. When it's just a single root, it's L alpha to the power of n plus m n beta to the power of n. So we have alpha and beta. We're told U1 and U2, so we can solve for L and m. So we're going to have L by minus 2 to the power of 1, so this is U1, plus m times 1 for n times minus 2 to the power of 1. So we're going to get minus 2L minus 2m equals minus minus 2, which I'll leave in that format for a minute, but we might need to change it around. Then u2 is equal to L times minus 2 to the power of 2 plus M times 2 times minus 2 to the power of 2. A lot of 2's. So that's going to be 4L. Then we're going to have plus 8M equals 12 from above. So what can I do here? I can get this into 2's. I can say 2L plus 4M equals 6. 2L plus 4M equals 6. So that's going to give me 2M equals 4, M equals 2. And if M is equal to 2, 2L plus 8 is equal to 6. 2L equals minus 2, so L is equal to minus 1. So my solution will become L minus 1 times minus 2 to the power of N plus M plus 2 times N times minus 2 to the power of N, subbing in here. And that's like junior cert factorizing. We've got two things by the same thing, so that's going to be 2N minus 1 by minus 2 to the power of N for my UN difference equation. The last part, we're asked to find U5. And U5 is going to be 2 5s are 10 minus 1 9 by minus 2 to the power of 5, which is negative. So 2 to the power of 5 is 32. So 9 by minus 32 is 270 and 18, 288 with a minus sign for the end of question